In this video, we are going to deal with the first question of exercise 1.1. And the question is, determine whether the function is reflexive, symmetric and transitive. And the relation given is R is equal to set ordered pair xy such that 3x minus y equal to 0. And the set given is 1, 2, 3, 4, etc. 14. So to check reflexivity, symmetricity and transitivity, the first thing we have to notice is the relation. And the relation is given as 3x minus y is equal to 0. And the second thing we need to notice is the set. Set is given as the numbers from 1 to 14. So what we will do is we will write R. R is equal to, the relation is given in set builder form. We will write it in roster form. Okay. So A, the first element in A is 1. So we will put the value of A as x as 1. Okay. So 3x minus y is equal to 0 gives y as 3x, right? So when we give the value of x as 1, y will be equal to 3. 3 times x. So 1, 3 will be the first element of R. Okay. And the next one is we have to put the value of x as 2. So when we put the value of x as 2, y is 3x, and when x takes the value 2, y will be 3 into 2, which is 6. We can take the next element. It is 3. When x takes the value 3, y will be 9. 3 into 3. When x takes the value 4, y will be 3 into 4, 12. And when x takes the value 5, actually the term will be 5, 15. But check, it is given that x and y are elements of A. So y also must be an element of A. Here we are getting y as 15, but 15 is not an element of A, so we can't consider the element. When we put the value of x as 3, y will be 18. So it continues like that, 6, 18, 7, 21, like that. So we have to avoid all these because both the elements of the ordered pair must be in the set. So we have elements 1, 3, 2, 6, 3, 9 and 4, 12. So to check whether it is reflexive, what we need to do is take the first elements of each ordered pair, 1, 2, 3 and 4. If R is reflexive, 1, 1, 2, 2, 3, 3 and 4, 4 must be element of capital R. Okay, so here 1, 1 is not there, 2, 2 is not there, 3, 3 is not there, 4, 4 is also not there. So conclusion is it is not reflexive. To check whether it is symmetric, what to do is take one of the element, 1, 3. So 1, 3 element of R. To be symmetric, for R to be symmetric, 3, 1 must be an element of R. For symmetricity, the condition is if A be element of R, then BA should also be an element of R. Here we took one element 1, 3 and just search for an element 3, 1 in R. 3, 1 is not an element of R, isn't it? So here in this set, 1, 3 is an element of R, but 3, 1 is not an element of R. Therefore, it is not symmetric. Okay, again to check for transitivity, the condition is if ordered pair AB, comma, we have to take one more ordered pair starting with B. So let it be BC, if BC element of R. If ordered pair AB and BC element of R, then AC should be an element of R for R to be transitive. But if we take an element AB element of R and there is no element starting with B in R, then automatically it will be transitive. Clear? Actually the condition is AB. If AB and BC are elements of R, then AC must be an element of R. But if you are taking an element AB such that there is no other element starting with the B in the relation R, then automatically relation will become transitive. So in this case, in our set 1, 3, there is an element starting with the 3, 3, 9. So 1, 3 and 3, 9 are elements of R. So 1, 9 must be an element of R, isn't it? So here it is clear that 1, 9 doesn't belongs to R. So how we have to write? 1, 3, 3, 9 element of R, but 1, 9 is not an element of R, which implies R is not transitive. So thus we are coming to the conclusion. In this case, R is not reflexive, R is not symmetric, and R is not transitive. Okay.